Morning, everybody. Obviously, I'm not going to be here again today, so I'm going to go ahead and record your lesson for today. We're supposed to do tutorial, but we won't do tutorial. We'll do tutorial tomorrow. Your test will be on Monday. But we'll be back tomorrow, so we'll do tutorial. So save any questions that you have until tomorrow. We're going to go ahead and go into the next concept. So this will not be on your test on Monday, but it's the next things we're going to be covering. And it's a huge concept for us. It's starting to solve some word problems. So the problem that we're going to be doing today are called DIRT problems. And DIRT is an acronym. It stands for D equals RT. You know what I'm going to do? I'm going to have you guys pause the video right now and then copy this stuff down, the stuff that's on the left-hand board and the right-hand board. You might want to do these on separate pages, so maybe this will be your first page and then that will be your next page, and then we'll keep going. Okay. This is the third problem. It stands for distance equals rate times time. Okay, so we're going to define that first. And so the D stands for distance. The I is equals, even though it's not spelled with an I. The R stands for rate. And T stands for time. And this is the equation that we use whenever we have a word problem that's trying to find the distance cars traveled, the rate that people were walking, or how long that it took them. So distance equals rate times time. So this is the formula right here. Distance equals rate times time. Remember when two variables are right next to each other, that means multiply. So this is distance equals rate times time. Okay. So we're going to take a look at a couple of different types of problems. The first one we have is a opposite direction, and we're trying to find the time. Okay, so whenever we do these, we're going to set up a chart. The chart looks like this. Charts are always the same. They always look like we're getting ready to play a big game of tic-tac-toe, except that we're not. So the first column here is the slow car, or the slow person, or the slow train, doesn't matter. And then the next one, of course, then would be the fast. And the bottom one is always total. Okay? So the column over here, slow car, slow person, fast car, fast person, and then the total. And then across the top, it's always rate, time, and distance. I will make a little note here that this one has got to be distance. You could actually switch these two, time and rate. If you wanted to switch those around, you could, but this column has always got to be distance, always. Okay. Again, make sure you're adding things to your notes. Don't just copy what I'm copying down. You know, the words that are coming out, that's critically important. All right. So now we need a scenario. Let's suppose that the slow car is traveling 6 miles per hour. So since the miles per hour is my rate, I put it in the rate column, and since it's a slow car, it goes in the slow column. So the slow car is going 6 miles per hour. Then the fast car is going, messed that up. The slow car is going 5, the fast car is going 6. Okay, so the slow car is going 5, the fast car is going 6. And then now we need their times. So for the time, we don't know how long the slow car is traveling, so we say that is x. Again, this would be in a word problem. I'm making it up as we go along. But this would all be in a word problem. The fast car is going twice as long. So let's say this one's traveling for 5 hours, this one's traveling for 10. This one's traveling for 4 hours, this one's traveling for 8. So the problem told me that the fast car is going twice as long. And then the last one is the total is the total distance that they traveled was is 48. So here's my distance right here. There's my total. So my total distance goes right there. Okay. We always do these the same. When we go across, when we're going across trying to find this one, we multiply. When we go across trying to find this one, we multiply. And when you multiply these, what I want you to do is I always want you to put the 6 times 2x. Okay, so 5 times x, use in parentheses, 6 times 2x. Don't put the number in parentheses, always put the variable in parentheses. Okay, so I multiplied going across. So we multiply going across. And then we add going down. So I'm going to add going down like that. So I have 5x plus 6 times 2x equals 48. And you see here, we just set up a multi-step problem, just like we were solving last week. 5x plus 6 times 2x equals 48. So if I work that out, that would give me how much time the slow one is traveling, and I can figure out how much time the fast one is traveling. Okay, let's take a look at another scenario. First thing I'm going to do is set up my chart. My chart looks like this. And the first row is slow, the second row is fast, and the bottom row is total. Going across here, it's okay for that to be time and this be rate. Those can be flipped from above, but this one has always got to be distance. You cannot have anything there except for distance. This time, we have two cars going in opposite direction, and they want us to find the rate. Okay, so this time we're trying to find the rate. The last time, we were trying to find time. So there's my time, it's my variable. This time I'm trying to find the rate, so my rate's going to be my variable. This one says that our slow rate, we don't know what our slow rate is. So if we don't know something in algebra, we put in x. And my fast rate is 3 times as fast as that. Again, all this would be coming from the word problem. We're going to take a look at a word problem in a minute. The fast one is 3 times x. Then the slow time is 3 hours. And the fast time is 4 hours. Okay, again, those came from word problems. And then their total distance that they are is 60. The total distance is 60. Okay? So I look at the word problem and I just plug in the numbers where they go. If it's a slow time or slow rate, fast time, fast rate, total distance, whatever. These are rarely given to me. Almost always we're going to be calculating those. So for this one, moving across, we multiply. So 3 times x is 3 times x, and I use the parentheses around the variable. This one is 4 times 3x, and the 3 also goes inside the variable, so it's this whole box gets put inside the variable. And then lastly, we add going down. So I have 3x plus 4 times 3x equals 60. Okay? So that's our second type. And our last one that we're going to do is going to be like this. Still a chart. And we have slow, fast, total, rate, time, distance. Again, distance has got to be the last column. And this one we have two things going in opposite directions. This time one of them is getting a head start, and that head start is in time, and they want us to find the time. So for this one we have our slow one is going 8. Our fast one is going 10. Our time is, our slow time, excuse me, is x plus 3. So that means they're getting like a 3-hour head start, and our fast time is just x. And then our total over here is 114. Okay, so all that came from the word problem. Then we're going to multiply going across as we did before. Multiply going across to get this one. So 8 times x plus 3. Here's where your parentheses become extremely extremely important. If you don't use parentheses, then you're going to do that part wrong. Then this is 10 times x, like that. And then lastly, we're going to add going down. So I have 8 times x plus 3 equals, oops, excuse me, not equals, plus 10 times x equals 114. Okay, so that's how we complete the charts. I'm going to point something out real quick. If you notice, we only added going down in the third column. Added going down, added going down. How you know if it's okay for you to add going down is in these boxes, we need to have both numbers and variables. For example, in these two, I only have numbers, a 5 and a 6, and there's no variable down here. I can't add going down to get this box. I'm not going to say 5 plus 6 equals 11, because nothing was going 11 miles per hour. It doesn't make sense. For here, I'm not going to add x plus 2x and give me a number here. I could add it down, but it doesn't do me any good because it's going to be 3x. What good does that do me? This one, I had a variable in this box and a variable in this box, and I had a number here. So it makes sense that I can add this one plus this one to give me my total of this. So this plus this equals that. Same thing here. A variable in this one, a variable in this one, no variables here, just a number, I can add going down. Variable, variable, no number, I can add going down. That needs to be added to your notes because that's an extremely important thing to understand. Okay, next we're going to move on to diagrams. So remember, press pause as needed. I'm going rather quickly today, but press pause as needed. So in this diagram, so now we're going to draw what these diagrams look like. These are called dirt diagrams. The diagrams you're going to draw whenever you get these word problems. So this first one says 2 cars going away from each other. All right, so if I'm going to draw 2 cars that are going away from each other, I start at a starting point. That's right there. Okay, so there's my starting point. And then I need 2 cars going away from each other. Now, almost always these 2 cars are going to be going different distances, or different rates, or different speeds. So when I draw them, I'm not going to draw them going the same speed. So I'm going to show that one is going slow, and the other one is going fast. How do I know that this is the fast one and this is the slow one? Well, the fast one goes farther. It makes sense. Faster cars are going to go farther in their distance than the slow ones. So that's my slow and that's my fast. Then we're always going to set this up the same way. And that is the top of my line, when I'm label this, is always going to be my rate. So on top of this, I would write the rate down. Okay? On the bottom of my line, I'm always going to write time. And then the total distance is always going to be from this point here to that point there. So this is my total distance. Okay? So that's how far the 2 are apart from each other. Okay. Take a look at this one. This one has 2 cars going towards each other. All right? 2 cars going towards each other. So we're going to start like we did last time with our starting point. Oh, excuse me. These have 2 different starting points. We're going to have a car here and a car here. Okay, so now we have 2 different starting points. And then, as we said, as before, one of the cars is going to be going slow. The other one's going to be going fast. So go ahead and let me put in my slow one. And we know that that's the slow one because it's a short line. And let me put in my fast one. And we know that that is the fast one because it's the long line. And then, same as before, the top of this line will be rate. And the bottom will be time. And the total distance is from here to here. doesn't change anything. For this one, I could write same, and it doesn't change anything as far as how we do it, and here we can write same. You'll notice that I left myself a little bit of space there because I knew I was going to come back and write the same there. Okay, so we're going to go ahead and fill in one of these. This one says, the example I have is going in opposite direction. So if it's an opposite direction problem, that must be this one, because here's where they start. They're going, one is going to the right, the other one's going to the left. So I'm going to be using this chart. It says a slow car is going 5 miles per hour. So my rate goes on top, and this is my slow car. So this is 5 right here. I put that 5 in. Again, this is from a word problem that I have. The fast car is going 6. Fast car is going 6. And then the question is, how long does it take for them to get 48 miles apart? So my total distance, how far apart they are, is 48 miles. And so what they didn't tell me anything about was my time. So I don't know about my, I messed that up. I'm sorry. This is the fast rate here. So that's a 6 there. What they didn't tell me about was my time, and so my time here is x, and my time here is x. So they started and stopped at the exact same time, so both of those are x's. There was not a head start in any way. Okay, so that's how you do it. And then you would take this information and plug it in here. We have a slow rate, fast rate, slow time, fast time, total distance, just like we have over there. So after you draw your diagram, you can fill in that chart. All right. Then we have these. These look a little bit different. This one, we have 2 cars going the same direction, and one catches up to the other. Okay, so that means we have 2 cars. They're going in the same direction. So they're starting at the same spot. They're going the same direction. So one leaves a little bit earlier than the other. So we'll go like this. So that's that one. And the other one catches up to it. So that means this one must have had some sort of delay, or this one got some sort of head start. So the way we show that is by putting this in. And this squiggle right here is the head start. Okay? It could be a time head start, it could be a distance head start, maybe this one starts a few meters or a few feet ahead or whatever, but that represents the head start. And then one is catching up to the other. Other than that, it's the same. On top of the line is rate. On top of this line is rate. On the bottom of the line is time. And the bottom of the line is time. Okay, and then this one, we have the distance is the same. So the total distance between here and here is the same. And that's important. Okay? Total distance is the same. Okay, we're going to hold off on doing this one right now because I want to get to some actual problems here and take a look at them. And they're here. So now would be a good time to pause the video and copy these down. I, of course, am not going to pause. I'm going to keep going. Alright, so I read this. And it says 2 cars going in opposite directions. So I'm going to draw that real quick. So I have 1 car there. There's a long one. There's a short one. Okay? So this is my fast, that's my slow. The slow car is going 5 miles per hour. Hey, it looks just like that one over there. 5 miles per hour. The fast one is going 6. There's the fast one going 6. How long will it take for them to get 48 apart? 48 miles apart. And so what they didn't say anything about was our time. So we have to assume that they left at the same exact time. Okay, so there's my my problem. Now I'm going to do my chart. I have slow, fast, total. Then I have rate, time, distance. Okay, so my slow rate is 5. My fast rate is 6. My slow time, I don't know my slow time, that's x. My fast time, I don't know that, that is x. My total distance is 48. Just like that. I took it straight from my diagram and put it into my charts. Again, use pause if you need to. Then, my last thing I'm doing is going across, I multiply. So this is 5 times x. Going across, I multiply. 6 times x. And then going down, I add. So my equation to solve this is 5 times x plus 6 times x equals 48. And then I solve that equation, and that will give me my answer of time. Okay, we're going to do one more here. 2 cars going towards each other, all right? So that means I have 1 car there, 1 car there, and I'm going to have a slow one and a fast one, like that. The slow car is going 8 kilometers per hour, or 8 miles per hour. So here is 8 right there. And the fast one is going 10. So there's my 10. And the fast train gets a 3-hour head start. They are 114 miles apart. So that one, the total distance here is 114. Now, the fast one gets a 3-hour head start. That's important because my time is not the same. Here, I used x and x because their time was the same. This one, they're not the same. So if the slow one goes for 5 hours, then the fast one goes for 8 hours. So it's the slow time and 3 more. We don't know what the slow time is, so we write x. So if this one is going to be bigger than x because it gets a head start, then this has to be x plus 3. Make sure you hit pause if you need to because this is important. Getting this step right here is critical to getting the whole problem right. If you get that set up correctly, then I think you're going to do the whole problem right. So here we go. We're going to fix our chart here. Set up our chart. We have slow, fast, total, rate, time, distance. And from my problem, I see that my slow rate is 8. My fast rate is 10. My slow time is x. And my fast time is x plus 3. I know that this is my fast time because it's underneath my fast rate. And then going across, I multiply. So I have 8 times x, again using my parentheses. Coming across here, I have 10 times x plus 3. And now I notice that I forgot something, and that something is this total. The total distance is 114. Like that. That's total distance. And my last step is to add going down. So my equation is 8 times x plus 10 times x plus 3 equals 114. Okay, so there's your notes for today. A lot of notes. This is a big concept today. Here's what I want you to do for homework tonight. I've set up several equations and then stopped. So I have 5x plus 6x equals 48. I have 8x plus 10 times x plus 3 equals 114. I have some others on the very first page of notes that you took. I want you to solve each of those tonight. So go ahead and use your multi-step equation techniques and solve those tonight, and we'll talk about them tomorrow. If you didn't understand this, no worries. The video's online. You can watch it when you get home tonight and add anything that you need to. I will be checking notes tomorrow. Please make sure they're good. I'll see you guys on Friday.